Hey everybody. This is a tutorial of the lab that we want to be working on, or the activity. You can see here series and parallel circuits basics, and here is the website we're going to look at. So all you need to do is, this is a Google form, highlight over that, click on this sucker, and this is going to bring us right to this construction kit. I say in the directions, you do not need to download anything. All you need to do is click on that little picture. Now you see this Phet simulation activity, and we are going to click on the lab button. So click on lab, and now we have this lab uh, desktop that we can play with. Now, over on the left are all of my elements. I can pick and choose from all of these things. The very first thing I asked you to do is just play around, see if you can build a circuit and whatnot. A lot of these things we should know: a wire, a battery, a light bulb, a resistor, a switch. We've never talked about a fuse. A fuse is a safety device. And by that, it means if I blow a fuse, it kind of opens up a hole in the circuit. And we can talk about that in the future. Um, I'm actually not so sure what the difference between this battery and this battery is. I don't really know that. But again, I'll play with that. You can play with that as well. If I pull something out, oh wait, there's the difference. That one's 1,000 volts. This one's 9 volts. So if you pull something out that you don't want, just highlight it like so. Click on it, press the delete button, that gets rid of it. So what we're going to do is we're going to build circuits and then test it. Things that I ask you to do. You want to change from electrons to conventional. We use conventional current, which means the voltage or the potential difference comes out of the plus side of the battery and travels into the negative side of the battery. You're going to build yourself some little circuits, as the directions say, with lots of different wires. I tend to use the light bulbs because the light bulbs actually show things, and there are 2 spots to connect the light bulb. So there's one spot. I want a switch so I can turn my light bulb on and off, and all of those things. And now obviously nothing happens. Close the switch and the light bulb turns on. Open the switch and the light bulb turns off. So then I ask you to play with different values. I say, here, build this. We need to draw a circuit. We don't draw circuits this way. We press that button, and this is kind of our circuit diagram with the switch, the cell or the battery, the weird looking light bulb. If I close the switch, now there's no bright lights like there was if I look at that, but that is essentially what we're looking for. Now, if I look at my directions, looking at the directions, again, that first thing we do, just play with some things. I say I want to make a series circuit. Make sure you have all that. Build a circuit. Here's a note, and I put this on twice. I'm asking you to draw the circuit, but obviously you're not going to turn that in unless you're taking pictures of this and sending it in to me. I made this a Google sheet, so you can just turn it in when you're done. So you're either going to write, I drew this on paper, and I'm going to believe you because we're trustworthy people. Or you can take a picture and stick it in there, or you can email me the picture, whatever works for you. I want you to answer the questions as we go. I ask you to play with some different values, like, there we go. If I think I wrote right click, but if I click on this, I can change the voltage of my battery. I can change the direction of my battery. I can take my battery out. The same thing with the light bulb. I can change the resistance of the light bulb. I can even change what is called the resistivity, or how much wire resistance they have. So I can put my resistance all the way up, change my resistance all the way down of the wire. Remember, resistance is just electrical friction. I can start a fire. If you are a morbid person and not the nicest, you can take the dog and put the dog in the middle of the circuit. But that doesn't do anything because it's, a dog. Dogs have high resistance. Still doesn't do anything. I'm curious. You should not ever do this to a dog. This would be mean. What'll happen if I use this big battery? Still nothing. Yeah, that's good. So we cannot electrocute the dog. So you don't even need to try. Anyway, that is what we're going to be working on Thursday and Friday. I will get you some feedback based on your worksheet from putting together series and parallel circuits and calculating all of that. The next lab, these are kind of the basics of just learning how to draw and, put together a circuit. Sorry, there was the other thing I wanted to show you. Let's put the battery back. Let's put the light bulb back. Oh, excuse me. Now, there are 3 different meters. This is a voltmeter. Voltmeters measure potential difference, and the way we measure a difference is by putting it around what I want to measure. So one goes on one side. This is like a little lead, touches the other side, and notice it tells me the voltage of the battery. The voltage going through the wire, the potential difference going through, starting at that one and ending over there. So it's like, woo, measures all that. If for some reason I do it backwards, that's okay. The number just reads to be negative because I'm reading it backwards. So that's what a voltmeter does. Put it back in there. This is the non-contact ammeter. Remember, amps are just how much electricity is going through it. So this little thing literally examines the electricity going through the wire. Or there is a realistic ammeter. The realistic ammeter needs to go inside of the circuit. So I didn't actually even talk about that. But what you do is you remove part of your wire. I now hook up my meter. And now I put a new wire in. Now this little gizmo, this ammeter, measures how much electricity is going through there. So again, this is the one I asked you to use. You just put the little target on the wire and it tells you exactly how much current is going through that wire. Excuse me again. That's all I have to show you on this little demonstration. We will talk about it also in our Zoom meetings, but that's it. Hopefully you have a little bit of fun with this. It is not nearly as fun as playing with real life circuits, but it's the best I can do. That's all I have for you. This will be posted on Thursday, and it's going to be due Monday or Tuesday of next week, followed with a couple things after that. As always, some of you have been really good with emails and questions. Any questions, just shoot me an email. Thanks, folks, and I'll see you soon. Bye. Also, I want to point out how short this was. 7 minutes and 40 seconds. Woo! Bye.